Good afternoon. Today we will continue to talk about digestive tract. Yes. So we started the part of the digestive tract. The first lecture was about the oral cavity, then about the esophagus, and now we will continue and talk about the intestine. So the major layers, you know, the same. What are the major mucosa, muscularies, and the cervical mucosa, which is the inner part, yes, of the wall, which consists of epithelial lining, lamina propria, and muscularis mucosa, and the epithelium. So in esophagus, we know the epithelium is stratified squamous epithelium, of course, it's non-keratin stratified squamous epithelium, but in the stomach, we simple columnar epithelium. Yes, simple columnar epithelium. Then is the lamina propria, which is the connective tissue, and the muscularis mucosa, which is a thin sublayer of mucosa. This is the layer of smooth muscle cell. Then the next submucosa, yes, which is the uh, connective tissue with blood vessels larger than vessels which are in lamina propria. Then are in some regions are submucosal glands, for example, in esophagus, not in stomach. Yes, and also is the submucosal nerve plexus. The next is muscularis, which has the many parts. So the major part is the two sublayers. Yes, the inner circular and the outer longitudinal, and between these is the nerve plexus. But in stomach we have additional. Yes, the third sublayer. It's the obliquous sublayer, and the outer serosa or adventitia. Yes, in esophagus we have adventitia. In stomach, serosa. So what's the difference between adventitia and serosa? Serosa is covered by mesothelium, yes, which is the thin layer of epithelial cells, and the adventitia is thicker, and it's like the mesothelium. Now we'll start to talk about the small intestine. Yes, this intestine, which has three segments. This is the duodenum, jejunum, and ileum. And the small intestine is the long structure. It's about the 5 meter. It's a really long structure with these three. And now about the layers. Yes, so here the typical these four layers. Yes, the mucosa with the simple columnar epithelium, lamina propria and muscularis mucosa. Then is the submucosa connective tissue, the muscularis. Here we have two sublayers, circular and longitudinal sublayers, and the outer is thin serosa. Yes, in serosa, which is the connective tissue, so the covering mesothelium is, and also here blood vessels, of course, the nerve fibers, um, and so the small intestine, yes, so which is the main the region where proceeds the active absorption. And for the active absorption, of course, is the important part the surface area. Yes, and here are the special such structures which increase the surface area. Yes, for the absorption, it's of course the important. And Uh, the, this at first. You can see here these circular folds. Yes, the circular folds are here. So the inner surface forms this circular fold, and this circular fold consists of two major layers. They are the mucosa and submucosa. So together, mucosa with submucosa, they form the circular fold, and they have such name, the plica circularis. So do you remember the such folds in stomach? In stomach, in stomach are rogae. Yes, the rogae. So the rogae are the folds with mucosa and submucosa. Yes, the similar are in small intestine. Here are the folds, and they have names like yes, and you can see it's the so it's mucosa and submucosa, which are the blood vessels and nerve fibers, lymph vessels. So these like then the mucosa, muscular, you know, sublayers, it's the nerve muscles, yes, the our back, main pteryx nerve, in, uh, like I said, and this is the mucosa, starting from the mucosa, mucosa, epithelial lining, here is the simple villi. So now what sublayers for this villi? Epithelial lining and lamina propria, they form villi. And the epithelial lining invagination create the glands, intestinal mucosal. Uh, Now the in epithelial in columnar cells. So two different types. They are cells, cells, and are goblet, secretory. So the epithelial cells with absorption of the nutrients, and the goblet cells for secretion the mucus. And microvilli. So I think you know, yes, what are the microvilli? Remember it or not? So they are the apical the structures, the typical for so the epithelial. Epithelial are polarized, which has two different ends, the basal part and the opposite of this uh, apical. Yes, the surface, basal and the apical. Basal because it's located on the basement membrane, and opposite of this is the apical surface. On the apical surface sometimes are the special structures like the microvilli, like the cilia, like the sterocilia, and the microvilli usually are for absorption, and they contain the actin filaments. Yes, um, so all these structures, yes, the plica circularis, yes, the plica circularis, villi, and the microvilli, all these structures increase the surface area. So the circular fold, they increase threefold. So the conifold increase the villi, and the microvilli in additional 20 so the fold, and it means the total surface area, absorptive area. It's the really such the large, it's about 200 meter. Now again, what we can see, yes, the wall of the uh, the yes, the foramina lymphatic vessel, and this lymphatic vessel has such name, it's the lacteal. So located in the center of each line. And also you can the and uh, they are intestinal into the they have colors and they form the brush border. So important uh, and they are the cells, so they have another one. So they are cells that are secret. They are such the small gland, yes, which has one and so basic, yes, the duodenum, the jejunum, and the especially well developed are the villi into the jejunum, into the middle. You had about the celiac disease, yes, the disorder of the mucosa that causes malabsorption and can lead to the damage or destruction of villi. So this is problem, disorder of villi. And the cause of celiac disease and immune reaction against the gluten or other proteins is an certain and the resulting inflammation of the enterocyte leading to reduced nutrient absorption. And you can normal damage numerous. So this is the example, not the one. Duodenum. So, in the one of the important the feature of the duodenum. In submucosa, in duodenal segment are the glands, duodenal gland, mucus secreting gland. They have such name, the Brunner gland. So, in which part of the digestive tract we have also the submucosal glands. So we know stomach in both regions or only in one of them. In esophagus, not in stomach. Yes, submucosal glands are in esophagus, not in stomach. You remember? I showed you the longitudinal sections, the cross sections of the esophageal glands, submucosal glands, and in the submucosa. And if you remember, I talked that when we see the stratified squamous epithelium, yes, in mucosa, and are the glands in submucosal layer, it means that this is the section of esophagus. But if are the epithelial lining, if are the columnar cells and mucous glands in submucosa, so it means that this is the small intestine, especially. So it's the only the one in duodenum submucosal gland. Yes, so this is the duodenum. Why? Because we can see the villi here and the gland. Muscularis mucosa, yes, thin layer, and duodenal, in duodenum. Yes, Brunner, on the region of the gastrointestinal with glands in the submucosa. So, mucosa, humor, and well, visible are these glands. Mucus. This is transitional to the stomach and the duodenum are composed of the glands the weird duodenal submucous. So, your so in duodenum also are the glands which are located in mucosa epithelial glands, but here are adrenal submucous large. So it's the another part, the jejunum, and so in the jejunum are well developed the circular folds, the villi, such in jejunum. Uh, they are the circular folds, the mucosa also are which are mucosa. Then in mucosa, villi, the circular sheath. So it means that your process acts as absorption. No submucosal gland. Can you see the submucosal gland? Mucosal gland? No. Yes, this is submucosal. Yes, Gigan. This no submucosal gland. What this is tricircular. Tricircular, which is formed by the and enter. So now about the epithelial layers. Yes, this which cover the surface of the small intestine, plus the goblet, enterocytes, which are these cells are very so about 0.2 very typical. So do you remember the which type of junctions usually are between the epithelial cells? So very close. Yes, the current the junctions are here. Tight junctions, current junctions. Then are the desicap junctions, desmosomes, uh, and the hemidesmus. So hemidesmus, the so the junctions between the basal part cells and the basement and the mitochondria. So they are intertwined with numerous very small, small microvilli with actin, and they are the goblet mucous cell in the columnar epithelium. They also the apical part of the cell well developed Golgi apparatus for the so so the file lamina propria with small blood, and in the center is the black cell, which is the muscle into the file. The epithelial line contains invaginate gland near the basal gland. Yes, now we shall form this gland. Enterocytes are here, are also the goblet cells and Paneth cells and endocrine. about the enterocytes and about endocrine. Yes, the endocrine and you can see many different types and the produced by the cells enteroendocrine and the endocrine cells in the stomach. Yes, endocrine cells which are in stomach and the endocrine cells which are in this intestine, they differ. So, what is the difference? The major difference. So, in stomach, these endocrine cells are the closed type endocrine. Yes, so they don't have contact with the lumen. But in the small intestine here are the open type endocrine cells, and they have contact with the lumen. So it's the endocrine cell, it's the apical part, and I hope you can see. Yes, the very which so are the sensory structure, like taste bud sensory, you know, located into the oral cavity. Yes, cavity, very small structures, sensory structures. They are with the very fine microvilli. Such microvilli have this micro have the endocrine cells, the very thin structures, and the basal part, the numerous secretory granules. But so which is the typical for the endocrine usually have such granules into the apical part. In basal part, numerous. So the sensory nuclei, like the sensors which are in taste. Yes, enteroendocrine cells they and villi, and then are the crypts. Yes, the crypts, invaginations, not very such the long tubular glands are here. So then I'll show you really very such the long tubular glands which are in so the large intestine. And this is endocrine. Yes, the endocrine cells with secretory granules and the apical microvilli. So which type of the endocrine cells they are? They are the open type. Yes, unlike the stomach endocrine cells, so are the closed type endocrine cells. Um, and so it's the crypt. It's crypt with enterocytes and but here in crypts are the special type of cells. They are the Paneth. So Paneth cells, well, visible cells, they are why? Because they contain the large, very acidophilic granules. Usually they are located into the basal part of the crypts, like this. Yes, these are these into the basal part of the crypts is the crypt. Yes, invagination, epithelial lining invagination from the basal part of the villi. And so the more upper cells are the crypt enterocytes, and the so the into the lower top are located the Paneth cells, which such very acidophilic granules, and these cells play important role in innate immunity because so these active substances which are secreted from these cells, they break down the wall of the bacteria, parasites, um, lysosomes. They secrete lysosomes, these cells. So Paneth cells are important cells of the intestinal tract. Yes, located the basal part of this tract. And of course are the stem cells. So immature, non-differentiated cells, from which cells forms the other type of cells, so which form this epithelial lining and which forms the crypt. Yes, it's the so. Now, how you think? Which segment of the small intestine is this? So, is it duodenum or it's jejunum? It's jejunum. Yes, it's the jejunum, and so the crypts you can see it's the crypt, and so it's very easy, yes, to find the Paneth cells, very acidophilic granules they contain, and these granules are the large granules, and the so the last part, last segment of the small intestine, it's the ileum. Um, which differ from other these two segments. Why? Because in ileum are not so developed these folds and the villi, which are the numerous in the duodenum and the in jejunum, but um, in ileum, so it's the many aggregations of the lymphoid cells. And they usually are located in the lamina propria, so it means in mucosa. Yes, in lamina propria. Sometimes they also are in submucosa, of course, in connective tissue. Yes, and they form the Peyer's patches. Yes, the Peyer patches. So Peyer patches, if the duodenal glands are the typical feature of the jejunum, Peyer patches are the typical for the ileum. Yes, the segment of the small intestine ileum. So, can you see this lymphatic tissue? It's the lymphatic tissue. Yes, here with aggregation of the lymphocytes. So, you know Peyer patches from the immune system? Yes, the Peyer patches. Peyer patches play the role of adaptive immunity. Immunity, they Peyer patches are the secondary lymphoid organ. Yes, where proceeds the activation of the lymphocyte. Peyer patches. If you remember, which cells, specific cells are so the in Peyer patches? You remember? Of course, the lymphocyte. Yes, and also for the Peyer patches are the some typical cells. The you don't M cells. You remember M cells? Microfolded cells, M cells. No, M cells. M cells, which the cytoplasm of these cells for the pocket-like such the structures, and in this pocket are located lymphocytes and also are located dendritic cells. So the cells which are involved in adaptive immunity. So microfold M cells activation when these lymphocytes are necessary. Then proceeds the activation of the also other dendritic cells, plasma cells, and all these cells, have their main. Um, so which secrete the cells secrete antibodies. Yes. So what is the function of dendritic cells? They are antigen presenting. Yes, antigen presenting cells. And of course, there are, and so this all these cells which of the columnar epithelial cells, yes, with microvilli, then goblet cells with numerous granules, yes, mucous enteroendocrine cells often cause the microvilli on part and they have contact with the human part of the cells typical to the secretory cells, numerals, the part of the rough endoplasmic reticulum. Yes, because they are protein, so the producing these stem cells. These stem cells so this part I think is clear. Yeah, they are. uh, so they are still. So in the first, this guy, villi the formed by the epithelial lining and lamina propria. Yes, into the center of each vilus, into the inner part of the vilus. Of course, the epithelial lining into the part of the vilus and into the central part are the blood vessels. Yes, they have so the blood. Then into the center is the lacteal. So what is the lacteal? Lacteal is the lymphatic vessel. Yes, the lymphatic capillary. And also the smooth muscle. Yes, the pain of the smooth muscle, which are from the muscularis mucosa. So this will okay now break up Okay, let's continue. Yes, uh, we we are talking about the small intestine. Yes, which has the three different parts. And now I want to show this part. This is this segments of the small intestine. The first one is duodenum. The next is the jejunum, and this is the ileum. Yes, the last one is the ileum. And now you can compare, yes, the differences between these segments. The first one, so uh, 4 layers are in all these parts. Yes, these 4 layers, and the epithelial lining. Which type of epithelium lines the small intestine? Simple columnar, yes, simple columnar epithelium. Yes, columnar epithelium, then the lamina propria and the muscularis mucosa. These sublayers of the mucosa are clearly shown in all these parts. Then submucosa, muscularis with 2 sublayers. Yes, the circular and longitudinal, and the outer is serosa. But now what is the difference? And you can see these so the plica circularis, which are the folds, circular folds, are developed into the duodenum and so in ileum. Then the villi, which are the structures formed by the epithelial lining and lamina propria, especially, so the well developed are in jejunum. But in duodenum, in submucosa, can you see these? So what are these structures? Which layer is this? So these layers are the, yes, the layer. So what is this layer into the jejunum? It's the submucosa. Yes, it's submucosa. So submucosa, and you can see so many such the Brunner's, the glands. Yes, the submucosal, the mucous glands. Have you any question? With what? So this is the submucosal layer here. Yes, surrounding with these glands. It's the submucosal layer, and the not such glands are here. Yes, so they are the basal parts, more darker stained, are they? Than this. Yes, so they are the basal parts of the mucosal glands, not submucosal. Yes, the submucosa, it's here, the connective tissue, submucosa, connective tissue without these glands. And this is here the submucosa with, so it's thicker, yes, submucosal with many submucosal glands, mucous-secreting glands. And these mucous-secreting glands, such glands, if you remember, are esophagus, yes, and such glands are also in so the duodenum, yes, not in jejunum. And so by this submucosal layer, we can so the differ jejunum and duodenum. Now what about the ileum? Yes, this is the last segment. It's the ileum. So in ileum, of course, you can see the are not so the manifold, are not many villi, but and the lumen is more such they have more larger and open lumen ileum. But here are such the special such aggregations, yes, more larger lymphoid tissues are here in ileum, and in ileum are the Peyer's patches, which are the secondary lymphoid organs. Yes, not such Peyer patches are in jejunum and ileum. So these three different so the parts of the small intestine. Yes, this duodenum with glands, submucosal glands. Then jejunum with so the well developed the numerous the villi, and ileum with pair patches. Yes, such pair patches with lymphoid organs with M cells. Yes, microfold M cells. And so now about the large intestine. Large in compared to the small intestine is the shorter. Yes, of course, it's, and the diameter is so they have more so the larger are they, and which parts are here? It's the, you can see here the cecum region, yes, ascending colon, transverse colon, descending colon, and then is the sigmoid colon, and the final part is the anus. It's the shorter, and now I have the question: proceeds any absorption or not in large intestine? Water and electrolytes, yes. Water absorption and electrolyte absorption proceeds in large intestine, and so it's the large intestine again, and you can see the wall forms such the sac-like the structures, yes. Sac-like the structures are the structures which is so the feature of the large intestine here. And now about the wall, about the wall of the large intestine, not the not villi, yes, not villi are here, but what are, so the epithelial, so of course it's the epithelial lining. Again, this is the simple columnar epithelium, and this epithelial lining forms such the glands. And which type of glands are they? How you think? By the shape. By the shape, by the shape, the parenchymal part, of course. Tubular glands. Yes, they are tubular glands. So you know, yes, the difference between the tubular and the alveolar glands. So the glands are they, so the which groups are in glands are the tubular alveolar glands, and also are the tubular alveolar, where is the both types of the such parenchymal parts, and also are simple glands and compound glands. Simple and compound glands. What's the difference between these? Simple glands, they have only one duct. Yes, and compound glands, they have branches of these branches of the ducts. Yes, and they are tubular glands. And so if you remember the glands in small intestine, yes, in large intestine, more such the longer such tubular glands are. So well developed are the glands, tubular glands, such long glands are here. And then it's the mucosa, of course, it's mucosa glands, lamina propria. And can you see these lymphoid aggregations, lymphocytes here? And you know the mucosa associated lymphoid tissue. Yes, lymphoid tissue. And so in digestive tract, in respiratory tract, yes, are such the aggregations, and together they form such the mucosa associated lymphoid tissue. So the part of this tissue is located in large intestine. Yes, and you know, in large intestine are the numerous the bacteria, some of them, so it's the potentially pathogens. Yes, so the lymphoid tissue is here. Yes, in the mucosa, of course, in lamina propria. Then muscularis mucosa is also visible, and this is the submucosa with large blood vessels, lymphoid vessel also is visible. And now about the muscularies. Muscularies external has two sublayers. Yes, two sublayers. It's the circular and the longitudinal. Between these two sublayers, of course, is in the plexus, but the longitudinal, so the fibers, they form three separate the bands. Yes, and these bands have such name, Taenia coli. Yes, Taenia coli. What are Taenia coli? They are the so the fibers of muscles, longitudinal in longitudinal layer. Three bands of these fibers are. And the outer is, you can see it's this rosa, again a thin layer of connective tissue, this thin layer with blood vessels. Yes, with blood vessels, and unlike the adventitia, here are not so many adipocytes. Yes, adipocytes are many in usually in adventitia. And so it's the mucosa epithelial lining, and which so these cells are columnar cells. Of course, they are the columnar cells, and mm, entero- and goblet cells. So in a large intestine are more goblet cells than in a small intestine. What is the function of the goblet? Yes, they secrete the mucus, which form the layer, the mucous layer on the surface of this epithelial, and it prevents these cells. And so in large intestine, so this layer is the thicker as the mucous layer because here are more goblet cells. Yeah, this is the wall of the large intestine, and you can see these columnar absorptive cells. Then are the goblet cells. Then it's the submucosa, and if you remember the submucosa of the duodenum, or this is the thin submucosa, thinner than the duodenal submucosa layer. Then is the muscularies and now start the hemorrhoids. So what swollen blood vessels in the mucosa or submucosa of the anal canal can cause a painful disorder called hemorrhoid. This common condition typically results from low fiber diet, uh, constipation, then also prolonged sitting or straining at the defecation, conditions that produce increased pressure on these blood vessels. Yes, and forms hemorrhoid. This external to this swollen this is the section of the colon, which is the large intestine. Yes, it's the mucosa, and this is the mucosa, then submucosa, and the muscular externa with 10 years circular layer and 10 years. And the mucosa, you can see this, so the cross sections of the epithelial, so the mucosal glands. Yes, the mucosal glands, long such the tubular glands. So they are the cross section of these glands. Yes, the tubular glands, and you can see these cells, the columnar cells, and in the center is the lumen. Yes, these glands and surrounding tissue. So between these glands, it's the lamina propria. Lamina propria with lymphocytes, the cells, of course, the are here, microphages, and so goblet cells and the enterocyte. So in the large intestine, enterocytes, they have such name. If the large intestine is the colon, these cells are colonocytes. They also are absorptive cells, but of course here proceeds the not so active absorption. Yes, which is in small. It's the wall of the colon. Yes, the mucosa with numerous glands, then submucosa, then is the muscularis here, and especially in this more high magnification is visible main pteryg or our Bach's plexus, which provides motor innervation of the muscularis. Now I want to show colonocytes. So what are colonocytes? Colonocytes are these cells, absorptive cells of the large intestine. Yes, and are they active cells? How you think? Yes, they are. Nucleus. Uh, how you think? This is the nucleus, yes, of the colonocyte. This nucleus is achromatic or heterochromatic. Please. It's dark. It's achromatic. It's not heterochromatic. It's achromatic nucleus. Yes. So more electrodense, so the parts of the nucleus usually are visible when this nucleus is heterochromatic. Yes, the passive. It's active cell. Why it's passive? Here proceeds absorption, not the nutrients. Yes, which so are absorbed in small intestine, but here proceeds absorption, the water absorption. And these cells are the typical, so the fluid absorptive cells. So why the typical fluid absorptive cells? At first, on the apical part are so the microvilli, not the brush border they form because only a few microvilli on the apical part. Then are visible, so the mitochondria and the more typical this. Can you see the spaces inside the cytoplasm? Yes, these spaces inside the cytoplasm of this cell. I think these spaces are visible. Yes, so usually these cells, which are the fluid absorptive cells, they have such spaces in inside the cytoplasm. Yes, a few microvilli. Then are these the spaces here? Yes, like these. So these spaces, mitochondria. So this is the typical fluid absorptive colonocyte. Yes, the colonocyte. And so and the final the part. Yes, the final part is the anus. In this, yes, and this final part, this epithelial lining is replaced by stratified squamous epithelium. So all other parts, yes, of the digestive has the simple columnar epithelium. Only in oral cavity we have the stratified squamous epithelium. Then stratified squamous epithelium is in esophagus. So what is the difference between stratified squamous epithelium, which is in oral cavity and is in esophagus? In oral cavity, the part of cells are keratinized. Yes, the partially keratinized are cells. So in a heart pilot, in gingiva, so the cells are keratinized. Not all cells, of course. but the cells are keratinized, unlike the esophagus, where these squamous cells are non-keratinized. Then starts the simple columnar epithelium. In stomach, it's simple columnar epithelium. In small and large intestines are the simple columnar epithelium. Only the final part, yes, of this large intestine, where is the anal canal, it's the again stratified squamous epithelium. And also appears the keratinized than the cells. So here you can see the mucosa of the recto-anal junction, and this is the really transitional zone. Why? Here in this part, where is the rectum? In rectum, rectum also, yes, it's the so the final part of the large intestine. In rectum is the simple columnar epithelium, and into the anus, yes, it's stratified squamous epithelium. So difference, is it visible, the difference between these epithelial lining? Yes, simple columnar epithelium here, simple columnar epithelium, and you can see so many goblet cells are here. Yes, so many goblet cells are here, and then it is replaced by stratified squamous epithelium. Yes, stratified squamous epithelium. And what about this layer? What is this layer? How you think? Under this? Yes. So this part, yes, the this part, and you can see also the tubule. Yeah, that like the glands, tubular glands are visible, and the many goblet cells are here. Then so stratified squamous epithelium, and what are these tissues? It's lamina propria. It's connective tissue, lamina propria, and so you can see many lymphocytes, because so it has the more contact with an environment, and also has this part has more contact with the so the foreign, the different or microorganisms, yes. And so no folds are in the large intestine, yes, no folds. So folds usually are formed by mucosa and submucosa. Yes, no fold. Only the rectum region is which has such folds. Yes, and this specimen is from the rectum as it narrows, approaching the anal canal. Yes, here, and you can see these folds are formed into the rectum region. Yes, rectum region, epithelial such the lining, and then so it's the mucosa and the submucosa. Of course, the submucosa is thin here. So it's the recto-anal junction. The anal canal is the site where there is a transition from the simple columnar epithelium of the colon to the stratified squamous epithelium of skin. Yes, of skin. So it means that these cells are keratinized. Yes, this squamous cell. This part is the simple columnar epithelium, simple columnar epithelium, and then is replaced by stratified squamous epithelium. And in this region, yes, where is the stratified squamous epithelium, which is the anal part, also are in connective tissue glands. Which glands? Sebaceous glands, for example, these glands. Yes, the sebaceous glands are here, these glands. And so these stratified squamous epithelium, I think, now is well visible. Glands and this. And now this is the this final slide. We can compare histology of stomach, small and large intestine. Yes, So this is the stomach. Yes, it's stomach. So what is this? It's the small intestine, and this is the large intestine. So what is the specific for each of these region? For the stomach, starting from the surface, yes, the inner surface, which is the mucosa. For the stomach. So can you see the pits? Yes, the pits in stomach, in vagination. And when the stomach is empty, sometimes also forms the fold. Yes, roga. This is the not in this, so the pits are visible. This only the pits are visible, and from the pits starts the glands. Yes, you can see the glands. Then, in small intestine, of course, not the pit, but here are projections. Yes. So, what are these projections? Villi. And from the basal part of the pit starts the glands. From the basal part of the villi starts the gland. What about the large intestine? So, no such the special structure. Yes, here and uh, if you compare the glands, or stomach glands, small intestine glands, and the large intestine glands, more longer, yes, tubular glands, more longer tubular glands are in large intestine, and so more darker stained parts. Can you see here? Yes, into the submucosal layer. Here also, but especially more are in large intestine. They are secondary lymphoid organs. Yes, lymphocytes, aggregations of the lymphocytes. Then, so the connective tissues and submucosal connective tissue, then the muscularis layer, and all of these, so the parts have the outer layer. What is the outer layer? Serosa. Yes, all these regions have serosa, thin covering layer. And now I'll show this. So the table, yes, which here all these structures are uh, in this table. At first, the esophagus, yes, which subdivisions has esophagus? Esophagus has the upper part, has the middle, and the lower part. Which type of so the mucosa with epithelium is here. Non-keratinized, stratified squamous epithelium. And do you remember the cardiac glands? Cardiac glands. Where is the transitional? Yes, the zone from the esophagus to the cardia, the small, so the part of the stomach, cardiac glands. And in esophagus are small esophageal glands. Then these glands are the mainly mucous glands, so in submucosa. Yes. Then interesting is the muscularis. Why is interesting? Because here are striated muscles. Yes. And the both layers, striated muscle in upper region, and both layers are smooth muscle in lower region, and mix the smooth and striated muscle fascicles are in the middle part. Yes, the middle 1/3 of the esophagus. And the outer is adventitia, except at lower end with is serosa. Then the stomach has 4 major parts: cardia, fundus, body, pylorus, cardia, and the pylorus are small parts, and they are histologically similar parts, and the fundus and the body, large parts, also are histologically similar parts. And Now about the cells. Yes, the mucous cells, the surface mucous cells and the gastric pits leading to gastric glands with parietal and the chief cells. So you remember, yes, the function, parietal cells. What is the function of parietal cells? Large acidophilic cells they are. They secrete hydrochloric acid and intrinsic factor for absorption of vitamin B12 and are the chief cells. Yes, chief cells. What is the function of chief cells? Pepsinogen secretion. Yes, and then lipase secretion, and so the but these cells, yes, the parietal and chief cells are only in the fundus and the body, not the torus. And the mucous cells are in all parts, and the endocrine cells also are in. And in submucosa, no glands in stomach, and in muscular layer, inner so it's then the middle is flat, so the outer esophagus, small intestine, the part, duodenum, jejunum, ileum, plica circular. Plica circularis, the fold. Yes, villi are typical with enterocytes, goblet cells, and the other also the glands. The glands creep, and these creeps are with Paneth cells and stem cells and the endocrine cells here, and the typical feature is the pair in the ileum. Uh, Submucosa, interesting is submucosa in duodenum. Yes, here are the duodenum, the Brunner's gland, possible expansions of here ileum, so and muscular layer, the small intestine, large intestine, has the part of the cecum, colon, and in large intestine also have appendix. Yes, so what's the function of appendix? Yes, it's a very important secondary lymphoid wife. Yes, and intestinal glands with goblet cells are muscular outer longitudinal band, and the covering mucosa at the rectum region. And the longitudinal element in the submucosa venom and then the muscular layer thickened at internal skin and so anal is adventitious. So for adventitia because it's difficult. Yes, to find the border of this channel. Is continuous, is built into the surrounding tissue. So I think the part is understandable. Have you any questions? So clear, yes, the wall of the small intestine. Yes, three different parts. What are the differences and the functions of the and the wall of the large intestine?